A is local maximum point. B is local minimum point. And O is a point of inflection. A point of inflection. This kind of inflection is called a stationary point of inflection. We'll differentiate later, okay? As a matter of fact, it's stationary just because the gradient is 0 at that point. A stationary point of inflection. I'll tell you about the non-stationary point of inflection later. B says draw the sign diagram for the gradient function. Everyone, attention please. Sign diagram for the gradient function. So to draw the sign diagram of gradient function, you identify your turning point. So there are, how many turning points can we see? 3. Okay. One is at x equals what? -2. One is at x equals 0. And one is at x equals 3. That's it. Okay. Now, let's pick this. What is that? After 3 is what? Positive. Between 0 and 3? Negative. Between -2 and 0? Negative. You see? That is how you know a point of inflection. Compared to this, it's alternating. So there's no point of inflection. Understand? But for a point of inflection, you see, what happened? There's no change. It means that point is a point of inflection. Then here, positive. Okay? Now, state the interval where the function is increasing. We talked about increasing function last lesson. Yeah, so want to give it a go. State the interval where f of x is increasing. Let's start with increasing. Yes, Nakita, you start with this one. So you say, sorry, y equals f of x is increasing. Okay, you can say for or when, something like that. Not when, as in when. See, no, not that. Not ask question. Did I get it right? Okay, yes?
When x is greater than or equal to -2.
She said for x greater than or equal to -2. Is that right? Is the curve an increasing function when x is greater than or equal to -2? No, they disagree.
Wait.
Less than or equal to? Is that right?
I don't think it's equal to, right?
What?
I don't think we include -2.
We always include it. We always include the boundary. Is that right, everyone? Do you all agree? Are you sure? Say that again. You have to state the rest. And yes. We are talking about when f is increasing. This is when the function is increasing. Going up. Just like the elevator. Going up. Okay? This is also where it is going up to here. Okay? Decreasing function is everything else. Right? It's decreasing from here to here, it's decreasing from here to here, and since we always include the boundary, we can just say it's decreasing from here to here. Does that make sense? So, y equals f of x is decreasing when, yes, -2 less than or equal to x less than or equal to 3. Questions? Draw a sign diagram for f of x. Let's try. Sign diagram for f of x, not for the gradient this time. We've drawn the gradient anyway. So, what are the points to identify?
-4.
-4.
0.
-4.
0.
Are you sure? Because if you're identifying the sign diagram, you want to know if it is positive or negative, right? Yeah, 0. Of course, 0. Sorry, my bad. 0, yes? 5. So for that, you consider the roots where it crosses. Yeah, of course. Where it crosses determine positive y or negative y, isn't it? Okay, so what's the first one carrying? Yeah, the first one on the left, like that. Negative. Do you all agree with her? She said negative here. Do you agree? Talk to me, please. Yes? Okay. Then the next one, between -4 and 0. Positive. Crystal K, you're next. Between 0 and 5. Speak louder. Sit right, sit right, sit right. Negative. Everybody agree with her? Okay. After 5, everyone? Positive. That's it. Okay? So I want the class to attempt your worksheet question. Wait, did we just do that? Oh no, I was trying to avoid the question. Okay, yeah, so the class you attempt 2. Attempt question 2 in your worksheet. And I was looking at this and I thought, oh, I didn't put the question. Instead of looking at this worksheet. Krista, what's the problem? You didn't sleep enough. Always sleep. Especially on Monday. I hate it when everyone is not alive. Like alive. Mr. Chang, this is question 1 in your stationary point worksheet. Yes. Unfortunately, I thought I was avoiding the question I put in the worksheet, but I wasn't. I was doing it, and nobody could remind me. Shame on you guys.
I thought you were. That's why you did that.
No, I'm not that nice. You know, I was looking at this worksheet, and I thought, okay, I don't want to put, and I was looking at the wrong worksheet. You know, you could have told me, you know.
Okay, my bad. Okay.
All right, so quickly, yes, sir. Can you see from there? All right, take a picture and bring it.
Okay.
Yes.
For the sign diagram, why don't you also draw the arrow on the left side?
Yeah, you could. Send to your WeChat. You have a WeChat? You have your phone? Okay, you can write it later. Quickly, let's focus on the question, just number 2, okay? Done? If you are done with 2, please attempt 3. Please don't start 3 in the class. I think you can always do that later. Attempt question 5. Once you are done with 2, attempt question 5. Did everybody hear that?
Yes.
Thank you.
I just stopped it.
Can you please focus and work faster, please? I have a lot to do. So we need to cut down our jokes. Thank you.
Wait, no. You factorize the 3 out. Because that is much easier.
I know, but then what's the answer?
We can write a lot.
So we'll do the correction together. Question
Wait.
5. I give you just 5 more minutes, please. Lillian, tell me if you're done with 5. Or any other person, because I noticed she has started 5. Has anyone started 5?
Yes.
Okay. 5 minutes, please. you done with 5? Almost?
Oh. And then they substitute.
Right.
3 into inflection.
Yep. What are they called?
Why?
I'll stop you soon. The period ends when? 12?
Yeah.
Okay.
For later on, when you want to compete.
咁即係負12同負7啦。
啊，我負13喎。我究竟攞出嚟
你係咪冇擺個負落去？你係咪冇擺個負落去？
Oh, because you kept the 9.
Oh, okay. The execution. Yeah. 然后再带回去。
You put it in purple. That's fine.
Quickly, we have a few questions to do together, and I want to explain point of inflection. If there is no need to do number 5, then I won't waste time. Is it easy for us to do number 5?
I guess so.
Yeah, so that means I don't need to do the correction because I wanted to do the correction over there. So please solve that on your own. Then we will do number 10 together and these two together. Then I can write some short notes on the inflection. Not yet. So.
就会上。哦，OK，因为他是讲那个 stationary point，一定 use the dividing by。我相信大概吗？这叫 nature。nature 的。concave upward or downwards？
这能吧？是不是现在 nature？OK。找一个方法。
Yes.
Typically value, this is not one of them, this is E. That's E. So you can choose E plus 1 or E minus 1. Yes.
Should be, yes.
So you can do two values of F. Yeah, so this side of the one is for F prime. So show the curvature in the same diagram. This is derivative. So gradient is positive, gradient is negative, so this is negative. Then the variance is then this. So show that, then you can now. No. Just to have an idea. So then you can now write your conclusion from the sign diagram.
Okay, everyone, can I have your attention, please? So I leave you to do number 5 and complete it on time. For number 10, I want to believe it might be, there is a similar question, I think, in number 9. So that's why I want to do number 10, then you can use the same idea to do number 9. So after this, I'll show you some demo. I had 1 or 2 more information. We will do this after then. Then after that, I'll write a short note on the stationary point, so we won't be doing much on that today. But you have the question, you are welcome to go ahead and start working on the stationary points problem. Otherwise, when we come to class tomorrow, it's a 45 minutes class, or let's say 40 minutes class. So the first 15 minutes will only be dedicated to that, and the last, say, 20 minutes should be dedicated to something else, so we don't drag this thing too much. Okay, quickly. Prove that this is less than this for every x greater than 0. Krista, this is the point where you listen. Prove that ln x divided by x is less than or equal to 1 over e for every x greater than 0. When you see this question, it is very likely that you don't know this is differentiation problem. And that is one, how you learn tricks in problems. That's why I intentionally brought the worksheet to this section. It's in your textbook I took it from. But some people will have thought of another way to prove it. But the best way to prove it is just see this as a function. Less than or equal to means it's always below this point, telling you this is a maximum point. So if the curve is like this, we're saying that every value you get cannot go beyond y is equal to 1 over e. Can you see that? If this is the curve representing this. Maybe we should put the curve online and see. Now, ln x divided by x. Can you see that? Okay, so y equals 1 over e. Did you see this? It looks like it touches it, right? Let's zoom. Just fiction. It doesn't touch it. Just pretending to be touching it. You zoom out. But it doesn't touch it. Okay? So we're saying, okay, worst case scenario, maybe it touches it, but it does not go beyond that point. This is simply maximum problem. Just show that the maximum for this function is this. And when we say something is maximum, it means every other point is below it. From that point below, it cannot go above it. So this is a maximum and minimum problem. Okay? So the first thing you do is, let that function, let it be, where's my phone? Let's go. Got it. Let that function be f of x. So what you are going to do is to find the maximum value of this function. First, you find the derivative of f of x. This is u over v. So you apply what rule? Quotient rule. V du minus u dv divided by v squared. So you put that somewhere in your mind. The first derivative will be v as x du 1 over x times 1, right? That's derivative of ln x. Yes? U is ln x. Derivative of v is 1, everything divided by v squared. So basically you have 1 minus ln x divided by x squared. Yes? That's derivative. And you know that at turning point, you see I'm not calling it maximum point. I'm not assuming. You cannot assume, even though we can see in the graph already. Right? So I'm calling it turning point, which is a general name. Or you can say a stationary point.